So, what forthcoming trends do you see in the field and challenges that are facing designers of these very, very complex SoCs that we see in our smartphones and tablets and other applications?
So, I mean, I think what's happening is, so I'll say in sort of in the 90s, we got very comfortable. And what do I mean by that? I mean that, progress in sort of the fundamental manufacturing technology and devices and so on and so forth was just, giving us performance. I mean, it's like everything got better. It's amazing. Like, it's, normally when you design something, you can't make everything better. You pick some subset of things that you make better and other things are not as good. That's just the way life is because, the previous design was also done by smart people. So, but with manufacturing technology, we had this amazing run where not only could you get more complex designs, they could be lower power, they would also be faster and amazingly enough cheaper to manufacture, right? Astounding, it's sort of driven the semiconductor industry for decades, right? I mean, it's astounding. But that's coming to an end, and everybody has recognized this. And so, unfortunately, because this trend was there for so many years, we all got very comfortable because, we had to just do sort of the obvious thing and things got better. But now I think so I think part of it is now we need to sort of wake up again in some ways, right? So we sort of you've got to get people excited again about doing design because I think there's a huge opportunity to do new things, right? Because now finally people are receptive. If I were at a major company, I would say, why bother? There's a risk here. I mean, this is a predictable path. I can do better. But now that's no longer the case. So I think there's an opportunity. I think there are a lot of challenges though, because the thing that we've been spoiled so far is we managed to make microprocessors really, really good. And what's nice about that is the general purpose. We know what we can do anything with microprocessors, right? And there's this nice decoupling between the design of the processor and software. And there's this nice, ISA contract, instruction set architecture contract. I mean, it's very, very clean, and everybody can make improvements and make contributions. But now we're seeing, but if to change the underlying architecture dramatically, like even an SoC is actually, I would argue, a dramatic change. It's very, very hard to take advantage of the hardware at the software level, right? So I think that's actually so I think we need to go back to a world where both the hardware designers and the people writing software work closer together. But we're sort of not used to that because there was this very clean separation and we all went our separate ways. In fact, it's funny now, it's like people almost don't even speak the same language. And so I think that's a big challenge that we're facing, that we need more people who can bridge that gap because that's where the benefits have to come from. Because we can't just rely on doing nothing at one level of abstract, the software level and seeing improvement. Those days are over. So I think that's a big challenge, and we don't know what to do about it right now. And people are talking about lots of different techniques, but the embedded systems community, which has been around for a very long time, I mean, I would argue that they haven't solved this problem, right? They've been grappling with this problem because they build these sophisticated devices that are all very specialized, and you have this block that does image compression, and this block that there's a processor, but then there's image compression. There might be cryptography, there might be video processing, all sorts of things in a single chip, and you have to sort of hand craft your application to exploit all of these features. And that's very time consuming. There's a reason we don't get a new phone every 6 months, an upgrade to all the hardware in the phone. It's a lot of work to map things to an architecture that looks like that, and that's where we are today. And I think we need to sort of move away from that and get back to a world where sort of the software can be decoupled from the hardware, but have some sort of contract so that you can exploit the features of an SoC. So if I'm a hardware designer and I say, hey, I have this great idea, I could do, I don't know, image recognition in this new way, way more efficient from a hardware and power perspective, and I put this block down, well, it should now be used automatically. We don't know how to do that. Whereas, in a microprocessor, I add more, ALUs and
everything just automatically gets faster without the software having to do anything.
It's amazing, right? It's a wonderful place to be, and it would be great if we were back there in the new world? And I think that's a very difficult question, and I think a lot of people are working on it, but it's a hard problem. But I think that's probably the biggest challenge, is getting to a place where we can once again ride we can once again ride technology and get improvements in performance without having to say it takes 10 years to rewrite some piece of software.
Professor Rajat Manohar from Cornell University. Rajat, thanks for joining us today.
Thanks very much, Dave.